So now, let's look at what happens is that you have car and you have a truck here. M1, the mass of the car is 1,000. And the mass of the truck is 2,000. Okay? And here is the driver, something we need to consider. And the mass of this one, let's go, it's just 80 kilograms. Okay. Now, what happens is the initial velocity of the car. What's the initial velocity of the car? What's that? 30. And what's the initial velocity of the truck? 5. Those are them to the right. Okay. So after collision, okay. So they stick together, they lock together, so they form one object with total mass m1 plus m2. And they share the same final velocity u. We want to find this final velocity, right? Okay? Now, if we apply the momentum conservation for any collision process, you can always apply the momentum conservation. P naught equals to P final. Okay? Initial momentum should contain two terms because you have two separate objects. So it should be m1 v1 plus m2 v2 equals to the final momentum. This is stick together. So you have only one term, m1 plus m2 multiplied by u. Okay? Any question here?
The driver in the car, I think he's 100 kilograms, about 80.
100. Okay, any other question? And by the way, this 100 kilogram is included in the M1, so you don't have to add it separately. So that's momentum conservation applied to this situation. Please note that it's derived from this general one. Okay. This is the general equation, and this is applied to this situation. They share the same velocity. So of course, this one will enable you to solve for u. M1 is 1,000, 30, 2,005 equals to 3,000 multiplied by u. You can check that u equals to, what's the final velocity? Okay. 13.3 meters per second. So that's the final velocity. Now, we know all the initial velocities and the final velocities for all the three objects. So we can use the same equation here to do the derivation. So first A, for the car, we just need to check the, make sure we put the right quantity for all these velocities and mass. For the car, F average equals to delta P over delta T. So delta P is the final momentum subtracted initial momentum. So for the final momentum, it should be M1 U minus M1 V1 divided by delta T, right? U is the final velocity for the car. V1 is the final velocity for the initial velocity for the car. And M1 is the mass of the car. So you get 1,000 multiplied by 5 oh, not quite, 13.3, right? Minus 1,000 multiplied by, what's the initial velocity for the car? 30 divided by 31. So you can get something in Newton. And then for the truck, similarly, it should be something like that, but you have M2, the mass of the truck. What is the final velocity for the truck? Again, U, right? Subtract M2 multiply what is the initial velocity for the truck? 5, which is V2, right? Divided by delta T. So it's 2,000 multiplied by subtract 2,000 multiplied by 5. Okay? Check which number we are using for each calculation. Now, finally, if we want to calculate the average force for the driver in the car, okay, what is the, so we need to put the mass. What is the mass for the driver? 100 multiplied by what is the final velocity for the driver? 13.3 and multiplied by 100 multiplied by what is the initial velocity for the driver? 30 divided by 4. So the calculation here is very similar with each other. You use the same equation, but be careful which mass and which velocity you are using for each term. Okay? Again, here you can see to find the final velocity, we need to analyze the whole system by momentum conservation, so we get the final velocity. And then to calculate force, we go to analyze each object with the momentum impulse theorem. Okay?
So anytime you're solving for a force, you're going to use impulse theorem?
Yes, of course, because from this equation, there is no way you can calculate force, right? The force doesn't appear in this equation. It only appears in impulse momentum theorem. And what I would like to emphasize is that where you are going to use it, this is for each object. This is for the whole system. And by the way, you can try to check your answer for this and this. You will see this one will be a negative answer. This one will be a positive answer. Does this make sense? Because you are calculating the average force acted on the car and on the truck. So they should opposite to each other. The car will receive a force in the opposite direction, so it should be negative. The truck will receive a positive force, right? So one of them should be negative, one of them positive. By the way, the magnitude of the two forces, can you say anything about the magnitude of the two forces?
Same.
If your calculation is correct, they should be the same, right? Because they are action and reaction. Okay, you can check that. So the two forces will be opposite to each other, but with equal magnitude. Okay, because they are action and reaction. But, okay, maybe exactly because we did some approximation here, but they should be the same. Okay.